we are moving on to 4.2. And today is all about trig ratios. Yes. Okay. So I know back in geometry you guys started talking about some of these wonderful trig ratios, right? And you were taught about SOHCAHTOA. Okay. So first of all, what I want to start with is one of the ones, SOHCAHTOA starts off with the sine of theta equals. And it's opposite over hypotenuse. I'm going to abbreviate it that way. The second one in SOHCAHTOA was cosine of theta, which is adjacent over hypotenuse. Anybody remember the third one? Tangent, that's what I was looking for. Good. Tangent of theta is opposite over adjacent. Now, what you didn't know is there are three more. Okay? Which are actually the opposite of each of these. So we actually have what we call cosecant of theta, which is hypotenuse over opposite. We have what we call secant of theta, which is hypotenuse over adjacent. And we have cotangent of theta, which is adjacent over opposite. Today we are working with right triangles, and we're going to find all of these ratios. Okay? So, one of the things I want to talk about first, I have this up here, is when we have a right triangle. All right. Wherever your theta is, so let's say your theta is in this corner. From this theta, the leg that is across and not touching it is the opposite. The leg touching your angle you're working with is called adjacent. Some people mix that up, so I just want to make sure I clarify. And of course, we all know that the diagonal across from the right angle is the hypotenuse. We do remember this? Okay. So the first few problems in our homework today, you are just finding those 6 trig ratios. So let's do an example of that. All right, so here is example number 1. And I'm actually going to get us a triangle here because I'm going to cheat my way. Here's my triangle. And in my triangle, let's make this, how about, we'll just do a 3, 4, 5 to begin with. And it's going to ask you to find the 6 trig ratios. And we're going to put theta in this corner. Bless you. And that is supposed to be an I right there. There we go. All right, so we're going to start with sine. We said that the sine of theta is opposite over hypotenuse. Opposite over hypotenuse. So from our theta, opposite is 3 over hypotenuse 5. Cosine of theta is adjacent, so the one that touches our theta, over hypotenuse. Tangent of theta is opposite over adjacent, or 3 over 4. Those are the ones you've been working with before. Now let's do their opposites. So we have secant of theta is hypotenuse over opposite. Secant of theta is hypotenuse over adjacent. And cotangent of theta is adjacent over opposite, or the one that's touching your theta over the one across from your theta. It's not so bad, right? Okay. So let's do another example. Let's say, let's go to the next page. Example number 2. Find the 6 trig ratios. And let me get my triangle up there. That looks good. Okay. Again, here's my right angle, here's my theta. But what if I only had, let's say, 5 and 7 written here? Can I write my trig ratios right now? We have to find the other side. And how do we go about doing that, Isaac? A squared plus B squared equals C squared. So, we have A squared plus B squared, or 25, equals C squared. So I have A squared equals, if I subtract 25 to that side, I get 24. And of course I have to square root that. Square root. So I get A equals. Now I can simplify that wonderful square root 24, right? What can come out of there? Oh, we got to leave it in exact form. Yeah, it comes out 6 and 4, and so 4 breaks down to 2 and 2. So we get 2 square root 6. So this side over here is a beautiful 2 square root 6. All right, so now we're going to start with our sign. Sine theta is opposite over hypotenuse. Can we simplify that at all? Nope. Looks good, right? Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. All right, let's do our other ones. I'm actually going to move this for a second to get that out of my way. All right, so we're going to do cosecant of theta is hypotenuse over opposite. 7 over 2 square root 6. What's wrong with that? In the denominator. But here's what I'm going to let you guys do today. Because that's not the point of this lesson, is to simplify the radicals. I'm going to have you leave it. Okay? The point of this lesson is to understand where the ratios are coming from. Okay? So rationalizing isn't part of this whole deal. All right? So you guys are good with that? Okay. So let's do the secant of theta is hypotenuse over adjacent, or 7 over 5. And cotangent of theta is adjacent over opposite. Any questions out there so far? No questions? Okay. So this is what you are doing for the first 1 through 8. Or 1 through 7, because we're doing odd. 1 through 7. All right. Example number 3. Example number 3 is going to be your 9 through 17. Okay? And it says, assume theta is an acute angle in a right triangle, satisfying the given condition, find the remaining trig ratios. All right. And then it's going to give you something like sine theta equals, I don't know, let's say 10 over 13. And that's all it tells you. So what we need to do is we're going to draw ourselves a triangle. Put it right up here. I'm going to put my theta in one of these little corners. On my triangle, sine is opposite, so 10 goes over here, over hypotenuse. 13 is here. So I have to find my third side. Again, I have to use the Pythagorean theorem, right? So I have a squared plus b squared equals c squared. So b squared equals 69. And does that simplify 23? It does not. So it's just going to be the square root. Okay? So this side is the square root of 69. All right, so now let's find the rest of our trig ratios. So we have the cosine of theta is adjacent over hypotenuse. So that would be the square root 69 over 13. The tangent of theta is opposite over adjacent. So from my theta, opposite is 10, adjacent is square root 69. Again, I'm going to let you guys keep it in radical form. You don't need to rationalize. Now let's do our other ones. Let's do the cosecant of theta is hypotenuse over opposite. Secant of theta is hypotenuse over adjacent. And cotangent of theta is adjacent over opposite. You notice I've been putting them across from each other so you can see that they just flip, right? You start to find the shortcuts there. So do we have any questions? You guys want me to do another one where the given ratio isn't sine, but it's something else? No, we're good? Okay, this is a pretty easy lesson. And I figure once you can do like 4 or 5 of them, you can do all of them. So that's why I took a bunch off. Okay? So we're on page 335, 1 to 17 odd.